Hello, and welcome back. In this lesson, we're going to learn about using interfaces for code reuse. So what is an interface? Well, an interface allows us to group up methods within a class-like file, called an interface. Inside of the interface, we simply define the different methods that would be shared among our classes with no implementation. That is, the methods have no instructions. This allows us to keep the methods of the interface very general. We can then have classes implement the interface, and each class can give the method different instructions. So you can think of an interface as a way to define a behavior that your classes may share. But each class's behavior may need to behave differently. So when you implement these interfaces, you can change how they behave inside of the class. Now, as I said, the methods within an interface are only definitions. It consists of their return type, their name, and parameters if needed, but they contain no instructions. This type of method is called an abstract method. So you'll define the instructions of the abstract method in the class that implements your interface. Now, your interface's abstract methods cannot be private. They must be public. Additionally, your interfaces don't use instance variables. Since your interface is not modeling an object like a class is, there's no use for instance variables to hold the object's properties. The interface is just defining behavior by grouping up method definitions. Let's now take a look at an example of what an interface looks like. I'm going to be building onto the money card superclass and the credit card, debit card, and gift card subclasses example from the previous Java 201 course. Now, these different types of money cards can be accepted at various locations, and we'd need a way to get the location that these cards are accepted at. So I've created an interface named acceptability to handle this needed behavior. Now, to create an interface, it's just like when creating a class, but instead of using the class keyword, we use the interface keyword, followed by the name of the interface. This interface contains just one method. You can of course have more than one method in your interface if you need. You can see that I've set it to public, with a string return type, and I've given it a name of location. It also has opening and closing parentheses for its parameters, but they're empty as this method doesn't require any parameters. So you can see that there's no actual implementation or instructions for this method. That'll be handled by the class that implements this interface. Now, this location method will be used to return back a different accepted at location depending on the type of money card. To do this, and to use the interface, we just need to have a class implement this interface. And inside of that class, we'll give the abstract method an implementation to give it some instructions. So here's an example. I've created two completely separate classes to handle the acceptability behavior of a money card being accepted at all locations, such as a credit card or a debit card, or being accepted at only select locations, such as the gift card. At the top is our accepted everywhere class. And similarly to how we can extend a superclass, right after the class name, we just use the implements keyword to have this implement our acceptability interface. Now, I've named the class accepted everywhere because in this case, this is going to give the location abstract method of our acceptability interface an implementation that returns a string saying that it's accepted at all locations. You can see that we've redefined the location method here. We're using the exact same return type of string. It has the same name, it has no parameters, and we've given it an implementation. So this accepted everywhere class, which implements our acceptability interface, can be used within our credit card and debit card subclasses to define a behavior of getting the classes accepted at location. They can both use this accepted everywhere class's location method without having to duplicate this same method across multiple subclasses. And if we ever need to change the behavior, we only have to modify this one class. Whereas if we would have put this behavior inside of both of our subclasses, we would have had to change two classes, making us work more than we needed to. Now, you'd likely create another class which also implements the acceptability interface, and you'd give the abstract location method a different implementation to handle a completely different type of behavior, such as for the gift card subclass, where it would only be accepted at select locations. So you can see that I've created the accepted select locations class, implementing our acceptability interface as well to handle this new type of behavior. So this example just shows the very basics of creating an interface and then having a class implement it. Now, one of the main benefits of using an interface is the ability to create an instance variable of the same type as your interface within your superclass, and then letting your subclasses construct new objects of the accepted everywhere or accepted select location classes to give those subclasses specific behaviors without having to duplicate a ton of code within each subclass. So you now know how to create an interface and implement it, but you don't know how to really use it yet. And that's what we'll be covering in the next lesson, as I'm going to walk you through a complete practical example extending the previous sample code that I just showed you. So we're going to build on to our money card superclass and subclasses example that we worked with in the previous Java 201 course to implement an interface for adding additional behavior to that program. But that's it for this video, and I'll see you in the next lesson.